Hello everyone, welcome back to the series of tutorials on C++. I am Deepak Nial and here we are going to talk about one of the most important topic in C++, that is standard template library, which is also known as STL. In previous tutorial we talked about templates and here we are going to talk about STL that offers proof of concept for generic programming with templates. STL defines powerful template based reusable components that implement many common data structures such as list, stack, array, etc., and algorithms that are used to process those data structures. Now let's discuss a bit of motivation. Why should you learn standard template library or STL and where this is going to be useful for you? I am assuming that you are a student or someone who is learning the basics of C++ and want to implement STL somewhere in your project. You might have taken data structure and algorithm course in your university, but that does not mean that you are an expert in everything and you can implement any code with full efficiency. So I hope that you might have implemented some of the algorithms on your own, but I'm quite sure that you are not planning to do so for all the algorithms in near future. Without much deeper knowledge of computer science, it's very difficult to implement an efficient version of these data structures. So STL provides you general purpose algorithms and containers to make your life easier by following means that I'm going to discuss now. So first of them is STL is correctly implemented and you don't need to debug or test their efficiency. Secondly, they are as fast as possible for general use. Third, they are easier to understand and maintain. And if you're working with a large code or bigger team, it's always beneficial to make your code easier and maintainable. So these things matters a lot when you're working in industry and it's going to help you a lot. So in short, by using STL, you can write clean code in a faster way, and by avoiding them, you can spend a lot of time reinventing the wheel, write the code with poor runtime and memory performance, and pushing all your deadlines. That's why I suggest you using STL whenever you are implementing the complex data structure like heap, tree, hashing, etc. So I hope this is enough motivation for you to start with STL and standard template library in your projects. So let's begin learning about STL and its various components. So STL has basically three main components. One is containers, another is algorithms, and third is iterators. We are going to discuss all of them here in much detail as much as possible, and later we will implement some of them so that it's easier for you to understand the concept and working of STL practically. So let's begin with the container now. So as the name suggests, container is something that stores a collection of other objects. So you could have container something like this. It could store integers, floats, strings, cats, and so on. As the name suggests, container is something that stores a collection of other objects or it contains some data. It helps us to implement simple and complex data structures like arrays, lists, trees, associative arrays, and many more. The containers are implemented as a generic class template, means that a container can be used to hold different kind of objects and they are dynamic in nature. As you can see here, we can use a single container like we are doing for list. So we can make a list of only integers or only strings or only floats or only characters. So we need to tweak it a bit and then we can store anything inside it. We are going to discuss this thing in detail. But as of now, let's move ahead and talk about multiple kind of containers that we have. So first containers that we have is sequence containers. Second type of container that we have is associative or non-linear containers. And this is further divided into two parts. One is sorted and another is non-sorted. The final container that we have is container adapters and we are going to discuss all these in very much detail in later part of this tutorial. The first two containers, one is sequence and another associative nonlinear containers. They are collectively known as first class containers. Now we are going to discuss all these three in very much detail. So let's begin with sequence containers first. Sequence containers are those kind of containers that represent linear data structures like vectors, linked list, etc. So I hope you are already aware about these kind of data structures like linked list and array, even if you are not aware about the vectors. So arrays are basically contiguous memory locations like this. And if you want to store some data inside them, you can store like this 1, 2, 3, 4, 5. And suppose its name is A, then you can access these elements using indexing like this element is on 0th index, this is on first index, second, third, and fourth. So if you want to access this 0th element, you have to use it like this. If you want to assign some new value to this element, you have to do something like this, and then you can assign 10 or any other value to this, right? Similarly, linked lists are such kind of data structures. They are not contiguous memory blocks, but they have some pointers. Head pointers point to the first element, and last element is pointing to the null. And now you can store some values here, like 1 here, 5 here, 7 here. So it's a value part, or you can say data part in every node. And another part is of pointer, which you can say next, and this next points to another node, right? So I hope you are already aware about these things. Now sequence container has such kind of data structures. So let's know about them in more detail. First of them is array, which is static contiguous array. Second is vector. It is also contiguous array, but it is dynamic and it is contiguous. So I am not writing this contiguous array here, but this is the difference between them. And vector is used very heavily. So we are going to discuss this in very much detail along with all its functions. Now the third data structure that we have in sequence containers is DQ, which is double-ended queue. If you have gone through data structure course, so I am sure that you know about DQ also. Fourth one is list. If you come across list in STL, so you should be aware that list means doubly linked list, and if you want to implement singly linked list, then you have to use forward underscore list. So most of the time, the thing that I am writing here are the name of templates, or you can say classes. So it's not going to be very difficult for you to implement these, right? So these are 5 data structures here that are in the sequence containers. So let's begin with the array first, and then we will talk about vectors, right? So if you want to implement array, you have to include a header file, which is array. So it's very much intuitive. You don't need to worry about it. If you want to implement vector, it's vector. So there is no problem. Now the syntax of array is something like this: array. Then you have to provide data type first, and then size of the array that you want to declare in the beginning. And after that, you have to give array name, right? So let me give you some examples. First example is, if you want to implement integer array of size 5, you have to write it like this. And if you want to name it array, make it something like this. You can also initialize the array. So you have to write like this integer 5, and I'm making its name ARR. Then write equal to sign here, and then 5 values. So this is going to create an array something like this: 1, 2, 3, 4, and 5, right? Now you can operate over this array using some operators. So I will talk about those operators first. So the basic operator that we have here is at, another is get, and third is this square bracket. And we use all these to access this array. So basically you will use all these three to access the array elements. And how you are going to access these array elements? So you can write arr dot at. If you want to access this 0, it means 0th index, so you have to write 0 here. If you want to access first, so you have to write first here. So in general you have to write I here, right? If you want to access ith element. Similarly you can use arr and I inside this square bracket. So you are already aware about this kind of syntax because we have read this syntax in C or C++ before. But if you want to use get function, first of all you have to include a header file which is tuple, include tuple, and then you can use this function which you have to do something like this: get, then I, if ith index you want to access, and then name of array. Alright, so you have to take care of these operators. Now other than this we have some other functions like front or back. So this front element returns the first element of the array and back returns last element of the array. So in this case, this front is going to return 1 and this back is going to return 5 because this is the first element and 5 is the last element. Alright. There are some other functions. So one of the function is size and this will return number of elements in the array. There is similar function which is called max underscore size. So you might be confused between these two functions sometimes, but size is returning the number of elements present in the array at a time, and maximum size is going to return maximum number of elements that array can hold. So it's basically going to return the size that we have declared here, which is 5, or at this moment because this array has 5 elements, so it will also return 5, and this max size will also return 5. There are some other functions like swap, s is small here. So it will swap all elements of one array with another array. So it's going to do something like this: a1, if a1 is the array, dot swap and a2. So you can imagine it something like this: 1, 2, 3, 4 and 5, this is one array, and another array is 7, 8, 9, 10, 11. So suppose this is array a1 and this is array a2. So this operation is going to swap the elements, and after swapping process this will become 7, 8, 9, 10, 11, and this a2 will become 1, 2, 3, 4, 5. You can run these programs because it's not that difficult. You can just create an array something like this and then perform all these operations. I am not implementing these arrays or these programs at this moment because there are a lot of functions to discuss. So implementing those might miss the concepts. So I'm going one by one, and then at some other moment or at some other time we can run these programs. Right? Now coming to some more functions, there is a function empty. So this function is going to return true when size is 0, otherwise it will return false. One more function that array have is fill function, and this will fill an entire array with a particular value. So what we have to do, you have to just use this kind of function. If array name is arr, write arr dot fill and make it pass some value. So if it is an integer array and has size 5, so the array will become like this, right? Because it is filling 0 in this array. If you want to fill some other value, you can pass some other value to this function and it will make those values here. Clear? There are two other functions that I want to tell you. One is begin and another is end. So these functions are going to return iterator that we are going to discuss in a while, or maybe in some other tutorial because it might be a lengthy tutorial. So this begin is going to return a iterator pointing to the first element of the array. So it should point to the this first element if we get something from here, right? And when we will get an iterator from the end, it's going to point to an element next to the last element in the array. So end is not going to point to this element, but it will point somewhere here. Clear? So this was all about arrays. And our array works fine when we have to implement sequential data structures like arrays, except it's static. And it means that we have to define its maximum size during initialization, as we have done above here, right? And it cannot contain elements greater than its maximum size. So if we are declaring this array of size 5, it will have maximum size 5. And if you want to store sixth element, it will not be able to store sixth element. Clear? Now suppose during the program execution we have to store more than its size, or if we are reading input stream of elements and we don't know the upper bound of number of elements, there are high chances of occurrence of index of bound exception, right? So this exception could occur, or unwanted termination of the program. So there are chances of a lot of errors. Clear? So we can do one thing. There is one solution that we can initialize the array with maximum size allowed by a compiler, which is around 10 to the power 6. So we can allow our array to have these many elements. But this approach is highly space consuming approach. Alright. So this is one thing, that this approach is highly space consuming approach. But just imagine that you have declared an array of size 10 to the power 6, having small lines here. But finally you have found that your array has around 10 to the power 4 elements. So you are wasting a lot of space here, right? It's always possible that your number of elements that you are going to enter in this array is way too less. That's why this approach is never used in programming. The solution to our problem is dynamic arrays. They have dynamic size, that is, their size can change during the runtime, right? We have a container library here, which is called vectors, and that is used to replicate dynamic arrays. So now let's talk about the vectors. Now we know that array is of fixed size and vector is of dynamic size. So if you want to implement this, you have to include a header file, which is include vector. So it's intuitive, you don't need to do much of these things here. Now after this, when you want to declare a vector, you have to write vector, then data type, and you don't need to provide size here as we provided in array, because in the array we need to take care of the size and we had to initialize it in the beginning. But in the vector we don't need to do so, because these are dynamic arrays and they can increase or decrease their size as required. So you have to write vector, data type, and vector name. So if you want to create a vector v1 of data type string, you have to write something like this. Even if you want to initialize this vector, you have to write vector, then provide data type here, then v1. And if you do something like this, 4 and c++, it's going to create a vector on the spot, something like this, and it will have c++ 4 times, right? So it's a string, and that's why I'm putting double quotes here, right? Now if you want to put more values inside this vector, you can use some other functions, and one of the function is push back. So you have to write push underscore back and then value. So this function is going to insert an element at the end of the vector. It's something like this, b1 dot push back and then maybe java, right? So it will end java here. We have some more functions available. One of the function is insert. We have to pass first argument as iterator, that we will discuss in coming lectures, and then an element. This method is going to insert the element in vector before this position pointed by ITR. So suppose we have a vector and this ITR is pointing to this location. So this element will be inserted before this position. Clear? If you want to remove an element from the vector, you can use this function pop back. This will remove last element from the vector and reduce its size by 1. Now we have an erase function with the vector where we pass itr position, which is iterator position, and it will remove an element pointed by the iterator, this that we are passing here. If you want to resize the vector, you can use functions like resize, and here you have to pass size type and value type. So this function is going to resize the vector to n elements, and if the current size of vector is greater than n, then trailing elements are removed from the vector, and if the current size is smaller than n, then extra values are added at the end of the vector, which are these values. So suppose you have a vector having value 1 2 3 4 and 5, and if you are passing 4 here, then this vector will become 1 2 3 4. So basically we are reducing this vector to 4. But if this value is 6 and we are passing 9 here, so this will become 1 2 3 4 5 and 9. So basically we are adding this 9 at the end of the vector, right? Now there are a few other functions that you should know about vector. One is swap. It will basically interchange the value of two vectors. So you can write something like this: vector1 dot swap and vector2. One thing that you have to keep in mind, that vector 1 and 2 are of same type and same size. Another function that we have here is clear function. All the functions are beginning with the small letters, and this will clear whole vector, but it will not delete the vector. Another function is similar to size function of the array, and it will find out the size of the vector. There is another function empty. It will return true if vector is empty. Next function that we have here is capacity, and it's similar to max size of the array. It will return number of elements that can be inserted in a vector based on the memory allocated to a vector. Then we have some other functions, and we have final these three functions that we are going to discuss at this point. So add function works in the same manner as it works with the array. So it will basically, if you want to find out something like this, so it's going to return you the ith element, right? And front is going to return you the first element of the vector, and back is going to return the last element of the vector, right? So this was all about vectors. Now let's discuss a bit about list, and then we'll wind up this subsection of sequence containers. So array and vectors are contiguous containers, and they store their data on contiguous memory. Thus the insert operation at the middle of the vector or array is very costly. And that means if you have an array like this, suppose you have 1 2 3 4 5. So I am just taking a small array, but it could be an array of a bigger size. And if you want to insert something here, so inserting will be very costly, right? And why it is costly? Because in this case, if I am inserting something at this place, I need to shift all these elements to the right, or maybe I need to shift all the element to the left. All right. So it will be a very costly process in terms of number of operations and processing time. That's why we have linked list here, and it's going to overcome this problem. All right. I hope you already know about the list. So we have something like this: node, then another node, then we have another node, and so on. It's a chain of nodes, right? Last node point to the null and head point to the first element. And every node has two parts like this. The first part that we have here is data part. It will store the data, and this next part in every node is a pointer, which we generally call next pointer, and this point to the next element. And there are chances that it might not be contiguous location. So what do you mean by contiguous location? In case of array, suppose this is 100, we are talking about address here, and it's an integer array, so we are sure that it will be 104, it is going to be 108, this will be 112, this is 116, and 120, and so on, right? Because we are considering that integer has 4 bytes. Now if you talk about linked list, it is quite possible that it is 100, and another part in this node is 104. Now we are not sure that it's going to be 108. It could be 108, I am not denying it, but it's not 100% sure, right? So it means it could be something like this, maybe 1008, something like that, or maybe it could be 2008, it could be 3000, and so on. So it means that all these memory locations are contiguous or connected to each other, or we can say that they are next to each other. But in case of linked list, they might be separated at different places in the memory, right? So that's how linked list solve this problem that we have talked before. Clear? So if you want to insert a new element in the linked list, we have to just create a node here, something like this. It will have some data, it will have next pointer. Now what you have to do, you have to just remove one pointer, maybe this pointer you have to remove from here. Now this next node is going to point to this data, and this next pointer is going to point to this node. So that's how it's very easy to insert a new element in the list. Clear? Now let's talk about the way we can implement linked list in STL. So when we are talking about list, it's basically doubly linked list. So you have to write list, then data type of the linked list, and then name of the linked list. And for that you have to include a header file, which is list, something like this, right? You can also initialize the list with some elements in the beginning. Suppose I want to create a list of integers, so you can write list 1 and then a curly braces having size 4. And similarly you can have other containers also using their class names. So we have already discussed what containers we have in sequential containers, but we'll not discuss them in detail here because we have already discussed a lot of things. Then there are a lot of functions, some of them are similar to array and vector, and few others are there as well, which we are not going to discuss in much detail here, but I will just tell you some of the functions that we have available here. And the functions are like insert, push back, we have push front also, then we have pop back, so it means we are removing element from the end. We can also eliminate or remove the element from the front. Then we have size function to check the number of elements. Using front we can find out the first element, or using the back we can find out the last element of the list. If you want to swap two lists, you can use swap function. We can reverse the linked list using reverse function and sort the list with sort function. We can take out some of the part of this linked list using splice. It basically transfers the element from one list to another list. And then we have merge function, and this will merge two linked lists which are sorted. So basically if you have one sorted linked list and you have another sorted list, right? So these two could have different elements. So basically what it is going to do, suppose we have list 1 and list 2, so you have to use l1 dot merge and L2, it will create a new list having 7 elements, 3 from here and 4 from here, right? Then we have multiple operators in the list like equal to compare the elements of linked list in lexicographic order. So if you have 1 here and 2 here, so these two lists are not equal. For two lists to be equal, all the elements should be equal. Similarly, you can use greater than, less than sign, or less than equal to, or greater than equal to. All these operators can be used to compare lists lexicographically. Alright, now I think we have discussed a lot of things in sequence containers. This lecture is already lengthy, so I will wind up this tutorial here at this moment, and in the next tutorial we will be discussing about the associative or non-linear container in more detail. I hope you will find this tutorial very interesting and it will be helpful for a rapid and effective software development. And I am also sure that it's going to help you a lot in competitive programming where speed and accuracy matters a lot. If you have any query regarding any of these things that we have discussed till now, I hope that you will put all these things in comments and I will try to respond back as soon as possible. So see you in the next video. Till then, thank you so much.